So let's take a look at the IDA project. I took a project from the textbook and I sort of simplified it so you'd have some practice with IDA. And that was this one here, 303C. So I'm going to use this Windows 2016 machine for this. And I'm going to shove the instructions over to the side because one thing about IDA is you really want a lot of room. One of my students paid his $5,000 and got IDA with all the fancy things, and he's the one that found the check-rain jailbreak. So he really spent a long time staring at big high-resolution monitors. It helps to have 2 or 3 big high-resolution monitors to do this stuff. But we're going to do it in this little one to do some simple things. So we're going to open one of your lab files you've already got. Oh, and let me adjust this so it doesn't cut off. Listening to me? There. Not listening to me. All right, I'll do it this way. All right. That'll probably do. Okay, so we have the malware here that comes in this thing. So I can launch IDA and just say OK. And now I can disassemble a new file. I've already got it here from before with the path leading to the binary collection and labo501.dil. So I'll just open it that way. Now when you load IDA, it's going to ask you, how shall I disassemble it? It has to make some assumptions. There are different ways to change the options. I've never used anything but the default options. But if you had some screwy thing that is different than the average code, you could adjust what it does here. I always just take the default choice. So now it's loaded. See, it's still doing things. There's messages going on down here. And here's the color bar, the navigation band, and now it's done. And see, down here it tells you the initial auto analysis has been finished. Because this is a very small file, it doesn't take long. If you load something bigger, it will take a lot longer. So now it has dumped me in. And as I warned you, you see a lot of junk. It shows me some subroutines over here in the functions window, but they all have sort of useless names. It shows me some code here in graph mode. But as I mentioned, this is the DIL entry point that is not obviously easy to understand. And even if I scroll down here, I don't see any readable strings or function names or anything very handy. And then it just stops without any arrows going anywhere. I see this all the time, so I always find this pretty mind-boggling and frustrating how to get started. So, but let's fix a few other things. There's not enough information in these boxes, so let's fix that. That is Options, General, and then it is turn on line prefixes and turn on some opcode bytes, like 6. Okay, now I've got addresses and the actual hexadecimal values showing, so that's somewhat useful. And now I can go to text mode with the space bar, and then I just see the code like this instead of in those boxes, all right, which still is not very helpful. So I need to find something I can understand. So what I'm going to do is find a function. I'm going to find a known Windows function. Now I can get to functions. Sometimes they're here in the tabs. But if it's not already in a tab, you go to View, Open Subviews, and you can get whatever you need. And what we need here is functions. So here's the functions. Oh, they were over here. Anyway, so I can see them all there. Now I can make this into its own little box, and I can maximize it. I can't make the font inside here bigger, but what I can do is sort them by name. And now I'm looking for something called Get Host by Name. So I can just type Get, and it will go down there. It's found these. Now notice something. This is a stupid sort. It put the capital G's together, but the lowercase g's are somewhere else. So I'm going to move below that and type Get again. Yep. All right. That's going to be irritating. How about sorting it again? There, now it puts the lowercase letters on top. Now if I type Get, I might get something good. And again, maybe not. Apparently not. All right, I don't know why I'm not finding it. Let's see, function name. Oh, I need it. Probably it's an import. It's not a function. That's why. I'm in the wrong window. That'll do it. Imports are here. Okay, now I feel better. Now I can sort and type Get. And there it is, get host by name in this little tiny font. This is a Windows API call. It does a DNS resolution. It will get the IP address for a domain name. And if this is malware, and I imagine it's going to do something like phone home to a command and control server, then this would be a very common place to look for an indicator of compromise. So here it's going to show me get host by name. So I can click that, and it will highlight both occurrences of that. And if I hit Control X, it will show me all the cross-references. So there are a bunch of places, 18 places in this program where it does DNS resolution. Now I happen to know which one is important to us. It's the one that has the +101 in it here. So if I double-click that one, it's going to jump to this call, get host by name, in the data segment, call get host by name. So this is just a call, and up here, it pushes something. That's the name. All right, so let me get to my code here. It loads an address of 19040, 19040 in there, and then if I hover over that, it's going to show me over on the right, this is RDO pix.practical malware analysis. It's showing me in that little box where this pointer goes, but I can get a better look for it if I double-click that offset. So here's the pointer to the string it's about to use to do a DNS resolution. If I double-click it, it will go to where it's stored, and here it gives me a preview of it. What this is where the address is stored. And now I can go to hex view, which is here, and you'll see here is the address I'm pointing to. And what this is a 32-bit address in little endian order. So this is the address 1001.91.94. And you can see here 1001.90 is where I am. 1001.91 is here. 1001.91.94 is here. So that is the string pointed to from that location. So this is it, and here's the string. This is RDO, pix.practicalmalwareanalysis.com. So it has some kind of preface here, some letters that are not part of it, and this part here is the address of the command and control server, the server it's going to go to, pix. So I've found the name of the command and control server for this thing. So that's one thing. Now another thing you can do is look for strings, and there are some nice suggestive strings here in the strings view. So I don't see it in my tabs, so I got to do view, open subview strings, and it looks like it's doing something screwy, so I'm just going to do, it's opening strings just in that one area or something. I'm just going to close this hex view and see if I can get it to knock it off. Go back to a normal IDA view. Let's try this. View, open subview strings. Okay, now I see all these strings. And what I'd like to do is sort them in order and then put in some backslashes. And I'll find some things that start with backslashes. 2 backslashes takes you to the root of Windows object tree, and now you can refer to things like server names and share names and commands. And here's cmd.exe/c. That is the beginning of executing a command line command in Windows, a 32-bit command line command, cmd. So if I double-click that, I will find the code that uses that, and see here it is. cmd.exe/c is used here, and I think I want to follow the xref. Right. It's highlight it, yep, and click on the word cmd, and then Control X. And it will show me the cross-references, and here's code that pushes an offset to this string. So I can go there, and I will see it's going to push something and then call something. So that gets me to the code that uses this string. Now I don't want to be in text mode anymore. I hit space to get back to graph mode, and here is the cmd.exe is here, cmd.exe. So I can go up here and I can sort of figure out what's going on here, even without reading the assembly code. The red shows it recognized Windows Windows API calls, and they're pretty obvious. So it calls get system directory. Now, if you know about Windows, the 16 bits of Windows, like Windows 95, are in C Windows System. But when they went to 32, it's C Windows System 32. So it goes to get the name of the directory, and then it has an if statement that can go one way or the other. If it's a 16-bit Windows, it goes to command.exe, which is the 16-bit command line in Windows. If it's 32, it goes to cmd.exe to execute it, and then it continues. So this is apparently executing a command that came from somewhere, and this malware is intended to run on either 16 or 32-bit pieces of Windows. There I see it creating a pipe. I'm just looking at the red strings here, and the gray things are good, readable text. So if I just go up here, now I see hi master and some information and then welcome. So this appears to be a bot that puts this machine under remote control and then sends a message back to the command and control server saying, hello master, I am this kind of computer, I'm under this control, and it gives them some menu of options that apparently includes an option to execute command line commands, which it will execute in either command or CMD. So, that's how you can read this and figure out what it does in simple ways. And so that's the bit from the textbook. And the next one is some challenges I got from the HoneyNet Alliance. I rewrote them because I didn't have access to the original binaries, but the HoneyNet Alliance had some of these, and they were good, clean fun. There are these files called crackmes, and because I was really sleazy when I compiled these, I didn't know how to include the library, so I had you download this DIL file and put it in there too for a redistributable version of C libraries so it can run them. So you download these and put them all in a folder. I put them in C IDA, and let's see what they look like. If I go here and go to IDA and then do a dir, okay, I have the first one here, and I have the library it needs, so I can run that crackme. So when I run crackme, it tells me you have to do crackme and then password. So I've crackme and I put in password, and it tells me fail. There is a right password, and I haven't figured it out. This is just a password guessing game. Now, quite a few of the techniques we've already talked about could find that password. You could use quite a few of the tools we've used before, but of course we're going to use IDA just for practice. So you go into IDA, and you load that crackme, and I just accept the default processing, and I'm going to say no for this debug stuff. And it processed, this bar is, okay, here I am, like I said, in some useless dead end, which is something to do with how it launches the 32-bit processor. So the easiest way to find good code is, since I ran it and saw that it prints something like fail, when you fail, I can just go to strings. And I don't see strings there, so I'm going to do view, open subview, strings. And right there at the top is fail. And then here's something saying you found the password. So that looks pretty good. So if I double click fail, then I get to where the data is stored for fail. And if I go to the cross-reference, it's going to show me the code that uses it, which is what I want. So I double click the cross-reference, and here I am. And now I can just read it. See, here is the usage message. So here's an if statement. It either prints the usage message because you didn't put in a password, or it goes here where it loads some string, top secret, and then it does some kind of string comparison. And based on that, it goes either one way or the other. And one way it says you found the password, and the other way it says fail. So it's extremely obvious that that's the password. And you can just read it without really bothering to read all the assembly code. You can just look at the names, at the readable strings and the general layout of how the arrows go and pretty much figure out what it's doing. So apparently the answer here is top secret. So that's what you want to do. And there's a series of challenges here that get harder and harder for you to figure out what's going on. And that gives you a little bit of practice using IDA. All right, let me stop this one.